Hi everyone, we are learning about two special trig limits today, which are pretty important. They come up quite often, and it's just way easier if you can remember this. So our first is sine of x over x, right? So in your calculator, go ahead and graph that in a Zoom 4 window. I think it's easiest to see, or Zoom trig, I guess, so that's Zoom 7, I believe. If you graph this, you'll end up with a kind of sine wave looking thing, but not quite. And what we want to know is what the limit as x approaches 0 of sine of x over x equals. Now, if you do the math on this, sine of 0 is 0, and obviously if you plug 0 in for x, you'll get 0, right? So I'll end up with 0 over 0 here, which does tell me that this limit doesn't quite exist the way that I want it to, right? I have to use something else in order to get an answer. So I can look at my calculator and see that my graph approaches 1. So most likely, I'll have something going on there. Alright, but most likely, my limit will be 1. Now, similarly, if I look at 1 minus cosine of x in a Zoom 4 window, so I've gone ahead and typed that in already. And if you didn't know in your calculator, if you unselect and select these graphs, it will choose to graph them or not. So if I look at my 1 minus cosine of x over x graph, again, if I plug in 0 for x, I'll get 0 over 0. So here, if I look at my graph, I see that I approach 0. Right, so this looks much more like a wave than my other one, but something's going on there, and then keep going. Right, but it looks like my limit will approach 0. And so that ends up being the case, right? So if I were to write an answer, I know that the limit as theta approaches 0 of sine of theta over theta is going to be 1, and the limit as theta approaches 0 of 1 minus cosine of theta over theta is 0. Now that being said, this one comes up often, right? This is one that I would remember, right? I would put a star next to this. This one does come up quite often. This one I've seen come up like once or twice, really, ever, on the AP test. It doesn't come up very often, but this one does come up, so this is one that I would be familiar with. And the reason being, because I can use this rule to come to a conclusion for slightly more complicated problems very easily. So if I take a problem like this, for instance, all that's important is that what is inside my sign and what is being divided are consistent. Now what I do find is that the limit as theta approaches 0 of theta over sine of theta is also 1. Right? All that matters is the ratio. Keep in mind that this is a ratio, so I'm finding the limit of a ratio, so it doesn't really matter what's top or bottom in this case because I'll just end up getting 1 either way, right? Obviously, something divided by itself is going to give me 1. Not true with this one so much, but with this it's true. And all that matters, again, is that what's inside my sign and what is right here in my numerator or denominator, depending on where sign is, they just have to be the same. So in this case, I have the limit as x approaches 0 of sine of 5x divided by 4x. So what I want is for this and this to match. So if I have a 5x inside of my sign in the numerator, I need a 5x in my denominator. I do not have that. I have a 4x. So here's what I'm going to do. I am going to rewrite the top. I'm going to just write x on the bottom, and for now, I'm going to kind of remove this 4 out of the denominator. So same thing as multiplying by 1/4, right? Now I need to introduce a 5. So in order to do that, I'll put a 5 here. Right? But as you know, I mean, can you just write a 5 because you want one to be there? No. Right? If you're going to divide by something, I'm going to divide by 5. I also need to multiply by 5. So I'm also going to multiply by 5. Okay? And what I end up with is exactly what I wanted. I have 5x here. I have the exact same thing here. Okay? And what I kind of have as a leftover is a 1/4, which again originated here. That was my original 4 in my denominator, so that's my 1/4. And then this 5 right here. And the reason why I have a 5 in the numerator is because I had to introduce a 5 in the denominator. And as I know, I can take a scalar out of a limit, so this 5/4 can go outside of my limit. I have sine of 5x divided by 5x. I know that all of this will be 1, and so my final answer is just 5/4. And again, I know this is 1 because this is my special trig limit. Alright, we will end up being able to prove this later very easily, but for now, you're just going to take my word on it. We don't quite know how to prove this yet. Right, but it does make things quite a bit easier. So it takes something that looks quite complicated and makes it really simple. Alright, next one. A little bit of algebraic manipulation needed here. So I have 2x plus sine of x over x inside my limit. Okay, now, what I want is just this sine x over x. So I can use my fraction properties and split this up into 2x over x plus sine over x. All of this inside my limit. Alright. If I want to, I can split this into 2 limits. I have the capability to do that. You don't have to do this step. In fact, I probably wouldn't even do this step, but if you want to, you can do that. I'm actually not going to do that. Okay. So I see I have 2x over x, so the x's will cancel. So I'll just have 2 here. And the limit as x approaches 0 of sine of x over x is 1. So my final answer is 3. Alright, last one. A lot happening here, right? So I have limit as x approaches 0. I have 5, sine of 2x, sine of 3x. Okay. So what I want is for there to be a 2x directly under my sine of 2x. I want a 3x directly above my sine of 3x. So I'm just going to split this up. I have 5. I have sine of 2x divided by something. And I have something on top of sine of 3x. Alright, so what I want is for a 2x to be here, so I'm going to write that. And if I'm going to put a 2x in the denominator, I'm also going to have to multiply by 2x. Alright, and I want a 3x on top here. So if I'm going to put a 3x here, I also have to divide by 3x. Alright, so what I end up with is I know, all of this is in my limit by the way, I know that this is going to be 1. I know this is going to be 1. My x's will cancel here. So all I end up with is 5 times 1 times 1 times 2/3, or 10/3. Right? Super simple. I would highly recommend that you write everything out. Right? If you expand what you're given, so you take your expression and you expand it, just give yourself more space to work with. I think it makes it much easier. It makes it easier to see. So that is how you use your special trig limit. That's how you use this. Again, this is the more important of the two, so that's what we need to practice. You have a worksheet here. You do know how to solve all of these problems now. So if you have not already started on this, then please start working on this next. Let me know if you have any questions. Otherwise, have a fantastic rest of your day.